Hello everyone, my name is Thor Magnussonö and I'm the principal investigator of the EU-funded INTENT project, which is running in the Intelligent Instruments Lab at the Iceland University of the Arts. I'm extremely pleased to introduce this keynote as part of our Moving Strings Symposium. Andrew McPherson is a professor of musical interaction in the Centre for Digital Music at the Queen Mary University in London. He is a composer, electronics engineer, and a musical instruments designer. At Queen Mary, he runs the Augmented Instruments Lab, where a lot of interesting research has been going on for years. And I suggest you all visit their website at instrumentslab.org. Andrew is the inventor of the Magnetic Resonator Piano, which we're talking about today. And we're very excited to have one of these with us here in Iceland for the foreseeable future. And we will be offering people access to the instrument regularly. This week we have a workshop on the instrument, and I'm really looking forward to hear how that has been, how people have experienced that workshop. In the work we do at the Intelligent Instruments Lab, we will be poking into the brain of the magnetic resonator instrument. And we'll be exploring the potential for artificial intelligence in the instrument that we're already so familiar with, the piano. So we're very excited to be working with pianists here in Iceland that are interested in this technology, and we will be kind of communicating with you in the future. But for now, I'd like to hand over to Andrew, and I'm very much looking forward to learn more about this beautiful instrument. So welcome, Andrew, and I'll hand over to you.
Thanks.
All right. Okay, there we go. Anyway, maybe I'll just suffice to say, check out our website, instrumentslab.org, and you can see a lot of the fabulous projects that people are working on. And here's just a little sort of slideshow of different things that we do. One thing that I would also highlight as relevant to this work is Bella, which is an embedded computer designed specifically for interactive audio and sensors. And this is something that's actually spun out into a company from the lab's research. And you can find more about that at bella.io. Right, anyway, this is often the place that I start talks like this, because it's a question that I will get sometimes, and I think many of us in the digital musical instrument space will get. Well, okay, why? Why do we need new digital musical instruments? Why are you designing instruments to begin with? Aren't existing instruments good enough? And of course, well, we seem to have more slide contributors.
I'm looking for a way to turn that off. If anyone knows how to turn it off, please.
Yeah.
Okay, let's just pause.
It looks like there.
Thanks. All right, off you go.
Okay. Great. All right. Well, thank you very much, Thor and Jack and colleagues, for having me here. I'm really delighted to be presenting this work and to be able to have a magnetic resonator piano set up in the INTENT lab, in the Intelligent Instruments Lab. And this is the instrument that I have set up this week. I think we were talking about it, maybe the fourth complete magnetic resonator kit, and also the one occupying the northernmost latitude. So I can't wait to see what you do with it, with your various AI experiments. I'm going to tell you in this talk kind of how the instrument came to be and how it's continued to evolve over a number of years. Just to situate this, this comes out of my work in the Augmented Instruments Laboratory at Queen Mary University of London, which is a team of fabulous PhD students and postdocs, which counts Jack Armitage amongst its alums. So really pleased that Jack could go from this lab to Iceland. If you want to learn more about the lab, you can go to the website at instrumentslab.org, and I'd encourage you to check out some of the projects that we have there. Now, I'll start this talk with a question that I think a lot of us in the digital musical instrument design space get a lot, which is essentially, okay, why? Why do we build new digital musical instruments? Aren't existing instruments good enough? Well, there are three answers that I usually give to a question like this. The first of them is that, of course, we make instruments because we want to make music. Simple enough. Secondarily, though, instruments are a really interesting sort of probe or investigative tool to understand the way that people interact with technology in creative contexts. And finally, it's interesting to build musical instruments because actually doing it well is really, really hard. It's not hard at all to make a digital system that makes some sound in response to actions, but to meet the expectations of trained performers is really not easy at all. And I like this quote from the HCI pioneer Bill Buxton, who says that you have 3 levels of design. You have your standard spec, you have your military spec, and you have your artist spec. And that the third of these was the hardest and the most important. This is not to say that we make instruments in order to make military systems. At least I certainly hope that is not how our work is being used. But anyway, basically, musical performance presents a really significant challenge. So we might describe these basically as the arts motivation, the human-computer interaction motivation, and the engineering motivation. And I'll kind of go back and forth between these in these talk. Okay, now nonetheless, we can come back to this question: do we really actually need more instruments in the world? In 2004, Sergi Jorda, who is one of the pioneers of this field, wrote that many new instruments are being invented and too little striking music is being made with them. Here in 2021, I would say the situation is largely the same. Oftentimes, our ability to create technologies outstrips our ability to explore their artistic implications. And just as an aside, I think that's one of the reasons I'm especially excited about the Intent project, is that I think there's a real deep integration of the artistic exploration of AI technologies. So I think it's not just about creating AI systems, but really unpacking what all of it means and how we can use it in performance. So I'm, again, really glad to be a part of this. Okay, but maybe we can turn the question around and say, well, okay, why do we still play these wooden boxes with strings and horsehair and rosin and other such traditional instruments? And I would identify 4 reasons that old instruments tend to be enduring. One of them is that it just takes a very long time to learn to play an instrument. And again, this is the place where new instruments really struggle, because who's going to spend the many years to achieve that level of expertise? But also, old instruments have well-known virtuoso performers who can act as role models. Existing instruments have potentially an established repertoire that people can learn, whether that's notated or just in the common practice through an oral tradition. And then also there are established pedagogical practices for traditional instruments. So we could basically break these down into 2 categories. The first of these is essentially an individual phenomenon of sensory motor skill, whereas the rest of them we could collectively group under a sort of musical culture umbrella. And these are the things that any new instrument that we create somehow would be useful if we could tap into one or the other or both of these things. So my observation then is that instrument design is not just about the technology, not even primarily about the technology. It's about performers and it's about culture. Now, it follows on from this, my suggestion that existing musical practice is an extremely valuable resource for designing new instruments. Now, by this, I do not necessarily mean that the existing practice has to be a centuries-old classical tradition or a widely spread popular tradition. Even if we're in an experimental space, we're oftentimes building on the values and the practices that we have had from previous technologies, from previous artistic projects, and where we can connect to our existing practices. I think this is extremely useful for new instruments. Now, it maybe is a little bit worth unpacking this, this notion of music itself. Oftentimes you'll see people say, well, I'm going to make a new instrument so that I can make music, and I can make any kind of music that I want. And this is, sort of admirably aspirational, but ultimately music is not monolithic, and it's worth asking some questions about this. In what context would the designer expect an instrument to be played? What kind of aesthetic ideas might the instrument suggest to the performer? Because any instrument is going to privilege certain notions of music over other notions of music. And indeed, any technology used to make instruments will do the same thing. And here I have the first of Thor is going to appear in this talk, I think, in multiple places, and that's not just because I'm talking here at the Intent Lab. These slides I've used in other contexts, but in this paper of epistemic tools, Thor writes that the piano keyboard tells us that microtonality is of little importance. The drum sequencer that 4/4 rhythms and semiquavers are more natural than other types, And the digital audio workstation assures us that it is perfectly normal to repeat the same short performance over and over in the same track. So essentially, any technology that you build for music is going to suggest certain things. And that is also a theme that I'm going to return to talking about the magnetic resonator piano. So the MRP is part of a family of instruments which are called augmented instruments. And this term generally is taken to mean that you start with an existing familiar instrument and you add something to it. So if this blue circle represents the set of techniques that are possible on a traditional instrument, then this red circle ideally represents the techniques that you could achieve on the augmented instrument. Now, in actuality, it's very hard to add something without subtly taking away a few things here or there. So it ends up looking usually a bit like this. And we'll see some of those examples later on for the instrument. So here we are, the magnetic resonator piano. There are several components to this, which I'll take you through. Maybe the most visually striking here are the electromagnets that are placed inside the strings or inside the piano just above the strings. The idea is that the electromagnets can make the strings vibrate even without the hammer having struck them. Now, the instrument needs a way of being performed, and this is going to be from the piano keyboard, but using not just sort of on-off MIDI, but also the continuous position of each of the keys, which are sensed continuously and allow a sort of a real-time modulation of the sound of each note. And then finally, there is a mapping between what happens at the keyboard and what happens inside of the instrument. And this is essentially the software element of the instrument, which is also very core to the instrument's identity. So we'll go through each of these in turn. Before we do that, though, I'd like to play just a short video. So if you have not heard the instrument before, if you haven't seen it at the workshops this week, then you have some idea of what it is that I'm talking about. If for some reason I've forgotten to share my sound, then somebody just speak up after a couple minutes. All right. So, okay, starting from the sort of history of this then, when I was first designing this instrument, I was a bit obsessed with this musical example here, which is how would you play a gesture like this on the piano? A note that begins softly, gets louder, and then gets softer again. And of course, we know that this is entirely impossible on the acoustic piano for the reason that the piano is a discrete instrument. It's a percussion instrument. You press the keys and it goes through a series of levers and a hammer strikes the string. And the implication of all of this is that it's not possible to continuously shape the sound of a note on the piano after it has been struck. Maybe possible to do a little bit of modulation with a pedal, but these are very subtle effects compared to what you would get on a violin or a wind instrument, for example. Now, what I did to attempt to maybe get around the percussion of the piano and maybe explore more of its resonance was to look at the ability for electromagnets rather than hammers to actuate the strings. So the principle here is that a magnetic field will exert a force on a ferromagnetic object, which is to say like iron, steel, that kind of thing. And therefore oh, sorry, because now I'm host, now I get the waiting room messages. And I can't actually do anything with that. So, okay, I'm just gonna have to ignore those. Therefore, an electromagnet can exert a time-varying magnetic field and therefore a time-varying force. And we can use electromagnetic actuators to cause the strings to vibrate even without any hammer striking the string. So in this example, we have an electromagnet, the current runs through it and the string is pulled up towards it. You turn the current off, the string goes back down, and then you can turn it back on again, etc. And you can modulate it at the frequency of the string or one of its harmonics and cause it to ring. Here's a picture of how that works in action. We have the electromagnets here, which are suspended on these metal brackets. And we have one electromagnet for each note of the instrument, up to 88 in total. Also inside the piano are amplifier boards, and this contains also a bunch of signal routing circuitry such that we can drive 88 electromagnets from a smaller number of audio channels running on the computer. And I'm not going to get into that detail, but I will later on. We can talk about that later, or I can point you to some papers about it. Here's the close-up of the electromagnets. There you can see that there's a gap above the strings of 1 to 3 millimeters, and this is to leave enough space for the strings to vibrate, but still be close enough that the magnetic field exerts a strong force on the strings. So that's the electromagnet part, but actually that is far from the full story of the identity of this instrument. The continuous key position sensing is, I think, in some ways actually more important to the artistic identity even than the electromagnets because of the kinds of techniques that it enables. So let's have a look at that. In principle, we could put lots of different kinds of signals through the electromagnets and get different timbres and frequencies and amplitudes. But what I really wanted to do was have this under the fingertips of the performers. But the problem that we have is that the MIDI specification, or at least traditional MIDI keyboards, are discrete in the same way that acoustic pianos are. And that's no surprise. MIDI was essentially designed to emulate the action of the acoustic piano. So how could we get a more continuous degree of control directly from the keyboard? This was my solution to that. I have a Moog piano bar, which is a commercial product, which is now really quite hard to find. It was discontinued in 2007, and it was an optical sensor for the piano keyboard. And the way it works is that it shines a light off the surface of the white keys and measures how much light reflects back. And from there, it figures out the position of the key. And for the black keys, it shines a light across the key, and then it can tell whether the key is pressed or not pressed. And what I did was to modify this scanner so that instead of just getting MIDI out of it, which is how it was designed, instead I pick up the raw signals from the photodetectors. And so this gives me a measurement of the continuous position of each key. So here we have on the right-hand side, a plot of one single key press, where on the top you can see the continuous position over time. The key goes down. That kind of sloped top, the raised top of that profile shows that there was a lot of pressure into the key because there's felt under the key. And when you press on it, the key moves a little bit. And then you can see the kind of bouncing of the key as it's released at the end. And then even within the short period of time that the key is moving, we get a quite detailed measurement of its velocity over time. And this kind of sensing also enables a number of different extended techniques, like kind of light taps on the keys or pressure into the key bed or other kinds of things like this. And we'll see what those do on the instrument in a little bit. Now, as I said, the piano bar is discontinued and extremely scarce, and also the modification that I made to it is something that's not very easy to repeat. So I've been working on a project to completely replicate this design into a new keyboard scanner, which does all the things that the piano bar does and more. And this is nearly ready to go. I've got some prototypes here, and one of these will be living in the Intelligent Instruments lab very shortly. And this one is engineered for reflectance sensing on all of the keys, and samples each of the keys 1,000 times per second and can transmit the continuous key angle to the computer. It also has RGB LEDs, so you can have various forms of feedback about the status of each of the keys. And then just a convenient mechanical thing is that if you remove that bracket in the middle of the scanner, it'll fold in half, so it's more compact to transport. Finally, then, I'll tell you about the relationship between what happens at the keyboard and what happens inside of the piano with the electromagnets. And this, too, is really core to the identity of the instrument. My goal here was, as an augmented instrument that extended the acoustic piano, I wanted to preserve the kind of feel and identity of the acoustic piano to a certain extent. And one way of doing that was to keep the general principle that one gesture produces one musical event, as opposed to pressing a key and having a whole sequence of things take place. And this led to three goals, which were not necessarily mutually compatible. One was to preserve all of traditional piano technique. Another of them was to add new techniques for continuous note shaping. And then the third one was to have it be no harder to play than the original instrument. In practice, it ends up being a compromise between these three goals. And you'll see that maybe some things that you could previously do are slightly different. And there are definitely a few new things to learn in encountering the instrument. But the general principles are, basically a simultaneous execution of traditional piano technique and new techniques. And then, basically what I would describe as normal gestures make normal sounds and weird gestures make weird sounds. And I think you saw that a little bit with, for instance, the harmonic glissandos that I played in the video at the beginning. So a general reflection then is that augmentation of an instrument is not free. You can add new techniques to an instrument, but especially if those new techniques are situated in the same gestural space as the old techniques, you might end up limiting some of the things that you could do before. And then, of course, there is this question of learning time, of sensory motor skill. And this is not something that there is an easy shortcut to, but I do think that wherever you can borrow from traditional technique, that is really very useful. So let's describe the goal then as this: maximize the creative novelty, but also minimize the relearning time. And here, it brings to mind the paper by David Wessel from 2001 or 2002, where they say basically that new instruments should have a low entry fee, but no ceiling on expressivity. And this is the kind of holy grail of musical instrument design, and one that I think is really maybe not achievable entirely in practice, and also leads to a whole kind of separate conversation about, well, what do we mean by entry fees? Is virtuosity really our goal, et cetera? And those are the kinds of discussions that I hope we can even unpack in the workshops this week. But let me return to my original diagram around techniques and augmentation. So if this blue circle represents the kind of hypothetical space of traditional piano techniques before there were electromagnets, then the MRP adds to the instrument quite a number of new techniques and new musical capabilities: extended sustain, you can play crescendos from silence, you can change the timbre of the notes, add vibrato, harmonics, bend the pitch, the things that you saw in that video. On the other hand, there are a few things that might be less familiar. The role of the piano keyboard has changed. One thing that some pianists, I think, find challenging about this instrument is that now holding the notes with the keys and holding the notes with the pedal no longer produce the same sound, because when you sustain the notes with the pedal, the strings will ring and gradually decay as they do on the piano. But when you hold the notes by holding the keys down, it'll continue to sustain in an organ-like fashion. You have to choose at some point kind of whether or not you want to use the resonator. The volume of the resonator system can be controlled by another pedal, which is played by the left foot. But this is another technique to learn. And then just working with these continuous key position gestures is a different relationship to the piano keyboard, which needs to be learned over time. So we can basically say that we have our new sounds, but then also our various unfamiliar techniques. Now, an observation that I have made is, as you can see, I am far from the first to make this observation. Performers use instruments in unexpected ways. Thor writes in this paper from 2010 that instrument makers actively design affordances according to their understanding of musical performance and composition. But that essentially the people who are learning a musical instrument are maybe more engaged in a process of getting a feeling for the instrument's constraints rather than engaging with its affordances. And that has absolutely been my experience with this instrument. I first started this project in 2009, and I've worked with quite a lot of composers and performers over that time, as I'm going to talk about in a minute. And I have learned so much from the way that other people have used this instrument. And it has consistently surprised me the kinds of musical capabilities that people have found in this. And they are very different in some cases than the affordances that I thought I was designing into the instrument. So, okay, so let's come back to the beginning then. And I gave you this slide earlier, and I said that the reason that I designed the magnetic resonator piano was that the piano is a discrete instrument, and that when you press the keys, you can't continuously shape the notes. From a kind of mechanistic, acoustic point of view, this observation is of course true, but in terms of making this as a description of my motivation for the instrument, actually this is a total lie. This is not why I built the instrument. And I think maybe I didn't even realize until some years later that it kind of wasn't why I built it. I sort of told myself this story that this is why I built the instrument, but actually the real reason is this. I was doing a PhD in music composition, and I was at the University of Pennsylvania. It was a traditional acoustic, sort of classically orientated composition program, not anything to do with technology. And up through 2009, I really had no significant compositions for solo piano. Now, I am not a pianist, actually. I took a few years of piano lessons as a kid, but I'm a violist primarily, as well as being a composer. And I find writing music for solo piano just incredibly scary. And that's partly because I don't necessarily have the pianist's natural understanding of what fits under the hands. But then it's also just because there's just this weight of repertoire for solo piano. I mean, just so many hundreds of years of different composers doing different fabulous things with the instrument. And what do you really say as a composer in light of that kind of repertoire? So my interest in the MRP then was not that I was fixing a problem with the piano. I think it's very important that instrument design is not problem solving, but rather that maybe by changing what the piano was about just slightly, that I would get a different creative inlet, which I could use for my own music. And indeed, that's what I did in my last year of, so the MRP comes out of my last year of the PhD at UPenn. The first performances were in 2009 of extended piece called Secrets of Antikythera, which has been released on the Anova label a few years later. And here's a video. I'll play a short excerpt of this video, which again is mostly a kind of a demonstration of the instrument, and then but you'll hear a few excerpts of the piece as well. Actually, maybe I'm going to take a quick pause here and see if I can admit the people from the waiting room, if it'll let me do so. Yeah, I'll do that. Hopefully that'll work. Okay, there we go. All right, we'll play a video then. Right. So that was where it all started, with that piece and a subsequent piece that I wrote for viola in the instrument. And at the time, I wrote the piece to be played with or without the resonator system, because I really, the fastest way to make a new composition played once and only once is to involve some complicated technology that is never going to work again. And so I thought, right, okay, fine. We'll write the piece so that it can be played on just solo piano or with the resonator. So the language of the piece is very much derived from the piano with a bit of extra. Strangely, this sort of opposite thing happened, which is that the instrument took off in its own direction that I might not have expected. And that started with this set of composer collaborations around Philadelphia in 2011. I worked with 6 composers to write new pieces for the instrument, 4 solo pieces and 2 duos. And from that process, learned quite a lot and ended up redesigning a lot of the instrument. Went on to another project with some composers with the London Chamber Orchestra. And I think at this point, we're up to about 30 different pieces. And each of them has been their own kind of adventure and their own process of discovery. Just a word about notation, actually, which is that people often ask me, how do you notate for the instrument? And when I wrote Secrets of Antikythera, essentially I didn't notate for the instrument. I essentially had a software patch that was recognizing particular things that the pianist was playing at different times and activating the magnets with different notes. But that's because the piece predates any of this continuous control business. It's done entirely with MIDI. And essentially, I had to be a bit there as a sort of technological facilitator to make sure that the digital score was matching what the pianist was playing at any given time. But when I turned this over to pianists in 2011, I told them, why don't you come up with your own notation system, and we'll just see what happens. And then kind of thereafter, when people ask me, how do you notate for the instrument? I say, well, I'm not going to tell you, but if you want to see what other people have done, I'm happy to share some scores. And that again is, and here we return once more to Thor, this time in Sonic Writing from 2019, saying that the attempt at designing notational systems to transcribe sound is fraught with difficulties, for such an endeavor is always a process of selective abstraction and classification. And that essentially, here we're talking about transcription, that the transcribers will have to fit what they hear into the symbolic language available, and that actually this process might make it even harder for them to hear certain specifics in music. And this is just absolutely true of this instrument, because there are a lot of dimensions of what the MRP can do, which have to do with things that are not naturally captured by Western notation, things to do with timbre or particular subtleties of pitch, that I think I have to leave it to each composer to decide what they prioritize. And I've actually found that a number of the pieces that have been written for the instrument have been semi-improvised in some cases, or the notation has been written as a kind of mental note for the composer performer themselves to work from, rather than an attempt to transmit a very precise technique to somebody else. So again, there's no easy solution here, but just to embrace the diversity of things that come out. Here's just a little slideshow of some of the places that the MRP has been. This one was a fun project back in 2012. Won Jen Ho is a printmaker, and she had a gallery exhibition in Aberystwyth, and I designed a sort of self-playing score, just held the pedal down on the piano, and this would just play in a loop to accompany this exhibition. In 2013-14, the band These New Puritans used the MRP on a really nice album called Field of Reeds, and there was a live performance at the Barbican amongst other things. That was pretty interesting. Did another composer collaboration in Los Angeles in 2015. 4 really nice pieces came out of that, some of which have been played several times since. It was used in an opera by Maria Kalliompä in 2017, which was played at the Opera Theater in Rome. And then some other projects like this is one with Jonathan Pitkin at the Royal College of Music, and then an extended collaboration with Xenia Pestova Bennett starting in 2018, which is still ongoing, and she's performed in a number of different places. Here it was at Café Otto in London, the Approximation Festival in Dusseldorf, and ultimately she recorded an album called Atomic Legacies. And this has two different pieces in it, one of which is called Glowing Radioactive Elements, which is a solo piece for MRP. And then there's also a piece together with the Ligeti String Quartet. And this is a really lovely pair of compositions, and I would encourage you to go check them out. Also used it on a film score. This is Christopher Robin, which was a kind of a summer blockbuster film that was released in 2019. The composer is John Bryan, and he recorded a number of MRP bits that feature amongst an orchestral score for this film. Now, as part of all of that process, the instrument underwent significant design changes. If you were watching closely on those early videos, you'll notice that it looked quite different than maybe some of the later photos I shared. So the very first instrument I built in 2009 was all done by hand on a PhD student's budget. So all the electromagnets were wound by hand, only 48 notes, and it was only played with MIDI. There was the piano bar, which was producing only MIDI data, and then a second keyboard on top of the instrument to provide a little bit of variety. But then between 2009 and 2011, I essentially redeveloped the entire thing, now spanning the entire instrument with kind of more professionalized mechanical assembly. I redesigned the amplifier circuits to be more powerful and have brighter timbres. And then this continuous key sensing was something that I worked on in 2010, which really changed the identity of the instrument. Now, between there in 2011 and the instrument that is set up in Reykjavik right now, the changes have been less substantial, but they have reflected a lot of years of experience. Things like making the connectors a lot more robust, making it easier to set up, having the magnets have detachable cables. I mean, this is just practical stuff, but it's really important when you're traveling all over the place and setting it up in different instruments. And then I think the biggest change that is about to unfold is to finally detach from the piano bar and make this work with the new keyboard scanner, which will enable a few new techniques as well. So what this was all about then was musician feedback was really important throughout this redesign. So some of the goals were to have a wider range of register, greater dynamic range, faster attack times so that the notes could speak more quickly, brighter timbres, maybe more degrees of freedom from the keyboard itself, and then finally the practical one of faster setup time. Now, these generally speaking have something in common, and what they have to do with is generally speaking relaxing constraints. So if we go back to this idea of there's the affordances of the instrument and there's its constraints, what I would find is that when performers of the instrument or composers would engage with it, they would explore its constraints. They'd say, what can it do? How far can I push it in this direction? And then they'd come back to me and say, could you make it so that I could push it farther in this direction? Could it play louder or faster, or have more of this kind of timbre? And so the redesign was about trying to keep the things that I had already discovered and kind of expand out a little bit more, but not to fundamentally change the identity of the instrument. Okay, so just to wrap this up then, I maybe extract out of this work and other work that I've done kind of 4 principles of musical instrument design that guide a lot of my work. One principle is that the materials are never aesthetically neutral. And by material, I mean this very widely. We could talk about strings or wood, but we could be talking about code. We could be talking about AI systems. We could be talking about circuits. And every material that we work with as a designer has certain idiomatic patterns, and that these patterns make certain ideas more obvious to the designer than others, and in so doing, they lead you in particular aesthetic directions. And that's certainly been the case with the design of this instrument. There are certain ways that the circuits in the code have led me to do particular things, and that I maybe wouldn't have anticipated to begin with. A second principle is that there is no such thing as a generic instrument. So there is no kind of general purpose instrument that makes general purpose music. Everything is always situated in some cultural tradition, but it can also be, it can find itself interpreted differently in different places. And then a third principle is that design is an exploration and not a force of will. Here, I really like this term bricolage, which is essentially describing a sort of a tinkering, I guess, in situ open-ended exploration, which is not necessarily goal-directed or doesn't necessarily know where it's going. There's a really nice paper about interaction design and bricolage practice here, and I encourage you to have a look at that. I think it's really relevant to what we do as instrument designers. And then before I give you the final principle, I'm gonna play you a little excerpt from Xenia's glowing radioactive elements and then tell you about how this came to be. All right, well, I'll stop it there. I'd encourage you to watch that whole video. So what is going on there exactly? Where are these strange chattering, sort of high-pitched, kind of scratchy sounds coming from? Well, what Xenia discovered is that when you press the keys just the tiniest little bit, they make this kind of chattery, slightly unpredictable noise. And then if you can kind of focus in on this space between off and on, and eventually you get into these very strange landscapes of noisy sounds out of the keyboard. Now, why does this happen? Well, in a sense, it's a bug in the system. There is electrical noise on the piano scanner, on the piano bar, and that is feeding through my software, which is trying to detect state changes in the keys. So it kind of ends up zipping back and forth between discrete states very quickly. That produces these discontinuous sounds that then when they go through the magnets into the strings, where the damper is only slightly lifted from the strings, you end up with these very funny sort of pitched, sort of unpitched sounds. It's an emergent phenomenon. It's something that if you changed any one of the many aspects of the system, it would completely disappear. And yet, Xenia has made it sort of core to one of the movements of her piece. It's not something I intended. It's something that she discovered, and it's something that she views as a very important part of the instrument's identity. And so that, I guess, takes to the final principle, which is that we just have to expect that other people will interpret our instruments differently. They will bring their own values, and sometimes you just have to be open to the most compelling outcomes being the ones that you would have never anticipated. So maybe we could say that creating an instrument, therefore, is not about solving a problem, it's engaging in an ongoing conversation. And I think I've been really lucky in this project to have this conversation be happening for such an extended period of time at this point. And I am really looking forward to the continuing conversation with the Intelligent Instruments Lab around how this instrument is going to be used. So I will wrap it up there. If you want to know more about what happens in the lab, instrumentslab.org is the URL. And hopefully we have just a few minutes for questions. Thanks very much.
All right, thanks very much, Andrew. I'm just temporarily reclaiming the host. You see, we enabled co-hosting in the meantime, but it seems that has not turned up in the meeting settings in progress. But it looks like it's still only me and you that can. We're in the meeting now, so so maybe.
Yeah, we could enable audio video for everyone.
Well, we can, just assuming that we have a room full of good actors now.
Well, that's true.
I'm happy to.
That's fine. I mean, and look, the talk is done, so it's less disruptive if somebody needs to. Just don't enable screen sharing.
Okay. So in that case, people can now do audio and video. So yeah, if anyone wants to pop up with a question, then please go ahead. David, are you coming with a question first? Nope, you're just joining us to say hi.
Thor says his video doesn't work. Does your audio work?
Yeah, I think
Okay.
so.
Okay. Yep. I can hear you.
Strange. Start my video.
Well,
there we go. Brilliant. Thank you.
Oh,
yeah,
so
I was wondering about this Zoom bombing and so on. We don't have to be that kind of careful. I mean, there's nothing worse than a Marvel movie is gonna, happen.
Yes. People have too much time on their hands.
Yeah. But it was interesting. Thank you, Andrew. This was really, really deep and profound talk, and so kind of interesting how you kind of explained the background to your instrument and the way that you've been working with it and so on. And I liked very much your final sentence where you say creating an instrument is not solving a problem, it is engaging in an ongoing conversation. So this is something that you have, for example, in common with Halldor here, who is doing precisely that with his Halldorophone. It's the continuous conversation with the users. So maybe a question that I could ask you is how much contact you have with the users of the instrument, and are you actively kind of improving it? Do you see this as a live project, or are you kind of parking your work on it and moving on to other projects? How do you?
Oh, that's interesting. I don't know if there's one single answer to that question. I'm improving it in certain ways. I think I would say I'm kind of polishing, maybe, that like the differences that I showed between the 2011 vintage instrument and the 2021 instrument. It's the same instrument for all practical purposes, but it is. What I'm trying to do is I'm actually trying to detach from it, in the sense that the biggest impediment to the continued dissemination of this instrument is me and my time. Like I'm at the point where I'm actually more of a burden than a help to this instrument, because if anyone wants to use it, then I have to be there to set it up. It's like there's this one kit, and it's it's all very kind of bespoke, and that's just not a recipe for letting people kind of run with it the way that they want. So, but I've realized that there's a few design elements that have made it difficult to have, number one, to have lots of copies of it, and number two, to make it so that other people could easily set it up and calibrate it. And those are the bits that I've been working on. And it's so that I can step back and let other people kind of take the lead of what the instrument is for. I have made a deliberate decision that I am not going to be, kind of closely involved in changing the fundamental artistic identity of the instrument, which is not to say that I'm not interested in seeing how that happens with other people, but it's just like, for me, it's a complete piece. It's, it does what it does. And it's got a substantial repertoire now, and I think that kind of stands on its own. So like when I do other projects, I don't necessarily try to connect them back to the MRP. The MRP is it's done in that sense. It's not looking for a different identity than it already has. But just to take, for example, what you'll do with the kit over the next 5 years, I expect will be very different than what I've done over the past 10, and that's fantastic. And I can't wait to see it. And I think that's maybe how it should go, is fresh ideas.
Mm-hmm. Yeah. We have a question from Gunnildur.
Yeah. Hi. I was just wondering about the instrument. Are there any other adaptations of it, like for other string instruments? I'm a harpist, so I'm kind of interested in other ways to, or on like a violin or any other. Has this technique been used on other strings than on piano strings?
Yes, in different ways. Now, first of all, I'd say that every traditional instrument presents its own opportunities and challenges. So leaving aside any technology questions. To do precisely this on a violin, for instance, wouldn't make quite as much sense, because in the violin you already have a different relationship to the strings than you do on the piano.
Sure.
It hasn't been on a harp, for instance. Probably the biggest challenge with a harp is that the strings are made out of nylon and not out of steel, so you wouldn't really be able to drive them with electromagnets in quite this way. The low strings, or the lower ones, are wound, right?
Yeah, are steel strings. But
Yeah.
the problem there is perhaps because they have a steel core, but then they are silk wound, and then there are silver or silk or steel things around. So
I see.
So there's a steel silk core. So I'm wondering, like, would that be a problem?
I guess that could work. I mean, it sounds a bit like the lower strings on the piano, which is a steel core with a copper winding, and the copper doesn't respond to the magnet, so the whole thing is not tremendously efficient. The low notes on the piano are quite soft when driven with the magnets, but it does work. So yeah, I think that could be done. I don't know if anyone has done that. I mean, I myself have done some electromagnetic stuff with vibraphone in collaboration with Cameron Britt and Jeff Snyder. They made an instrument called the M-Vibe using the same sorts of techniques. Beyond that, I mean, I've seen a lot of people have contacted me about electromagnetic actuation. There's been some things published at NIME and other places. I mean, everything from drums to Fender Rhodes to what have you. And I can't remember if harp is amongst those, but it's definitely worth a look.
Yeah, I mean, we use often like a EBO, which is of course used for piano, something like this. I'm sure this is not anything similar, but in a harp that works, but it responds super slowly and like very, very soft, and that's and on piano it just works immediately, like woo, with a really clear tone. But with a harp it's really a problem, because it like takes forever to activate the string, and then the result is just so extremely soft, but the sound is very, very cool. So it would be such a nice I would be so interested in finding a technique to make that more.
Yeah, that would really be interesting. I mean, the other way to approach it would be maybe more as Haldor does, or Adam or Chris, where in terms of using speakers or actuators on the soundboard as mode of feedback, then coupled to the vibrations of the strings. In a way that can have more flexibility, because you're not quite so determined on what the string will or will not respond to, but it also produces a very different beast.
Yeah. Thank you.
I like the idea of that. Maybe you should come and visit us, Gunnhildur,
yes,
with your
totally.
harp. Yeah.
Very interested in that. Yeah.
Anytime, welcome.
I saw a question in the chat from Inesh saying, seeing the contents of the red circle achieved using a piano augmented with Max MSP, does Max figure in any of this? Good question. No, I'm not using Max in any of this. It's all sort of custom C++ software written for a particular purpose, but there are other ways of doing feedback and doing actuation of pianos, and I think there are other people who have used languages like Max for this. Like, for instance, you could you could in principle write a Max patch that would take data from anything, even my continuous key scanner, and then drive the magnets. There's no reason that it couldn't be written in any language, even if it would kind of lead you to different ideas maybe. But there's also been some work putting speakers inside the piano, and then taking a live mic feed from the piano, processing it and putting it back in. So there's lots of interesting ways to do acoustic electronic feedback, and I think basically everybody probably takes their tools of choice. And yeah, for me that was a different set of things, but it could be Max. Yeah.
Let me get audio on.
Yeah.
Speaking of that, is it possible in your software to easily decouple any of these features, or do you always have to basically write new software for the Bella? Like if you want to change the harmonic behavior, like take that off or something like that. Basically, is there a way to facilitate easier execution of a piece that doesn't use all the features?
Yeah, there's some of it is already done. Some of it's already available in the software. there's essentially some configurable elements of it. There's basically there's an XML file which describe and like different where you can describe different kinds of sort of synths that it can create, and you can have different parts of the keyboard assigned to different synths at different times. You can move around between those. So if you want to turn off some of that stuff, you absolutely can. Or if you want to change the behavior of it slightly. I also experimented with a thing involving some kind of organ-like drawbars where you could change the harmonics on an external interface. But I haven't kind of incorporated that back into the main tree of the software. There are a lot of things that the software doesn't do, or like assumptions that it makes, like for instance that every key event is coupled to an event that's going to take place on that same string. So like if pressing a key and having a collection of different things happening inside the piano is not something that software is going to do. And at this point I'm kind of not interested really in trying to unpick that, because the software is very good at a specific thing that it does. But if you want to prototype with it, I also have some simple max patches which can be used to tell the controller to send this or that audio channel to this or that string, and then you can basically write whatever software that you want. And I mean, there's a MIDI spec for the controller. You just send it a message that says this amplifier listens to this audio channel, and then at that point write the software of your choice. And it's not wonderfully documented, but I'm happy to provide any information needed to work with it.
Relatedly, is there any existing repertoire for custom software of that nature where people might have to do something radically different or have some kind of agency?
Yeah, good question. Well, one thing is that there's a question about where does the identity of the instrument stop? Like at what point is it no longer a magnetic resonator piano, but somebody else's instrument that just happens to use the same technology as the MRP? I think maybe that's a decision that the creator of the instrument gets to make rather than me. Again, the conversation element of it. In terms of the things that are using my complete hardware kit with other software, there hasn't been anything fundamentally different. Jeff Snyder wrote a piece that involved playing different harmonics on the strings at different times. It's wonderful, and it's such an expression of Jeff's kind of microtonal aesthetic as well. And he wrote it so that you'd play different. It was the very first version of the MRP, so there were two keyboards here, and the upper keyboard you'd play different MIDI keys, and that would change the harmonic that would be played of each subsequent note. And so basically every event was actually two keys, a harmonic plus the actual string to be played. And I can't quite remember how we integrated that in. I think we did use my software, but with a kind of funny XML file that was able to switch harmonics. Tony Salitro wrote a very nice piece for the instrument in that same project that involved playing an audio sample of a voice through the strings toward the end of it, and that wasn't supported in the software, so we just had to have basically another bit of software that was kind of ready to go, and I would have to trigger that at the end of the performance. But I don't think anybody's kind of taken it all the way back to first principles at this point. David, you had a question? Or no, sorry, Tab, you had one. Yeah.
I have an understanding question about the thing which is in front of the keys, which measures the wide, like what is wide, you said. So does that mean, because as a pianist you're getting taught to do like certain movements with your hands, does it track that as well? So could you, for example, kind of like conduct the note with your gestures?
That's a lovely idea. Yeah. That sensor doesn't do that. It's basically shining directly on the key, and so ideally it shouldn't see your fingers. It should only see the keys, because you're much more likely to accidentally bump it than you are to be able to do that. But that sounds like the kind of thing that you could do with like leap motion or something. You could to be able to sense the space around the keys in a really effective way. Is that sort of thing you have in mind?
Yes, because from my perspective, I always try to make the movements that you do to play the instrument a bit bigger, so it can be more of an intuitive thing and also more like a performative thing for viewers to understand. And I was thinking, when you designed what it does, for example, if you keep pressing a key, did you decide that yourself, or did you collaborate with pianists as well? Because you are taught to some extent to do like certain movements, for example, like the conducting, let's say, to use as a dynamic expression, which does not result in a sound, but pianists do like weird things.
Mm-hmm.
Did you estimate that before or research that, or was it this like more, because some things seem to be like very parallel?
Mm-hmm. So this question of designing things with or in response to feedback from players, this is an interesting one. And I wrote a paper about this in 2012 in Computer Music Journal, which talks about this collaboration with these 6 composers. One thing that I've found is that it's oftentimes not very productive to try to kind of query a panel of people about what they want before you start. You kind of, because you ask pianists, what do you want in your piano, and you would never get an answer like this instrument. You would get like, well, I'd like it to be a little louder, or I'd like it to be a little this or a little that. On the other hand, I think if you kind of come in with a sort of first offer, if you will, here is a thing I did. This is my artistic statement, this instrument that works this way. Then people are going to say, oh, that's really interesting, but what about this? And this kind of thing would never be something they would have thought about before that. So I think I'm a real advocate for making the first statement be your own statement in this space, but then having the second statement maybe be the one that is the response to the players. So did I do that? Yeah, I think I did to a certain extent. After when those composers were coming in to work on this instrument, I think there were certain techniques that I would have added that would have been in response to their one example. Actually, is when I first started the instrument, I had this really dogmatic notion that there should be no controls other than the keyboard. The keyboard was going to be everything like that because that's basically true on the piano, and I was not going to see it have 50 different knobs, and so therefore I was going to have 0 besides the keyboard. And that absolutist statement basically extended to include there shall be no volume pedal. Why would you need a volume pedal? You can continuously vary the height of the keys. So if you want to play softly, just don't play the keys as hard. Now, practically speaking, that is really not very easy. And there's to just hold the keys halfway down. But then also I just found with working with a lot of composers, they really wanted to have different kinds of volume changes. So eventually I relented and put a volume pedal in there. And that's become really fundamental to the identity of the instrument since. Like Xenia plays that a lot as part of her performances. So yeah, I don't know. I mean, I don't know what the general answer is, but it is, it's a back and forth.
I think that makes sense. Yeah.
Yeah, if I can just comment on that last thing you said, Andrew. I think there's when remixing known elements to a new unknown recipe or novel recipe, that new instrument tends to tell you and the users what it wants to be in some sense. And then it becomes a hedging of what is your feeling and what just becomes the overriding demand for what the users want. And it's an interesting game to play.
Yeah, it is interesting, I think. And you can never really quite anticipate, I think. But I think also, well, I don't know how you approach this, but I don't necessarily always say yes to the requests that I get. In fact, maybe I more often say no, and it's not just because I'm lazy and don't want to implement things. It's because I do have some notion of the artistic space that this is occupying, and it's like certain things would fit with that and certain things would not. But I'm getting to the point now where I think in kind of turning over this kit and making more of them, that it is essentially a kind of, it's a release of sorts that I hope and expect to see it go in maybe more radically different directions than I've taken it thus far. And I think it's gotten to the point of maturity where that makes sense.
That makes complete sense also to me, where I've been reticent to create a more controllable system because I like some of the wilder interactions that happen with the Haldorfon style of feedback. But having said that, when I leave an instrument with a composer, I'm perfectly happy with them using whatever tools they want to tame it to their liking. But so I think there's something about that personal artistic statement there, that you have a vision and you have the right to kind of control that to an extent. But then the beauty of instruments is that the players will always adapt them, and I guess have always adapted them to their specific style and desire, as also the composers. So it seems like it's perfectly in line with the tradition so far.
Mm-hmm.
All right. Jack had to jump and get a parcel somewhere, and I'm now the host. I'm just wondering if there are any final questions or comments that we would like to ask Andrew, or... So I think we should just wrap up now then. This has been a really, really interesting talk, Andrew, and a really good resource for what I think and hope will be an active community of MRP users, performers, composers here in Iceland. And we're looking so much forward to kind of explore the boundaries of your instrument and explode them, of course, and see what happens. I think your final words there were really interesting. You have something that has become mature. You are able to now to kind of concretize the design of it, and then start to ship it out and see what kind of development of the instrument will happen in the hands of the users, as opposed to you actively continuing developing the instrument. And to me, it seems that the instrument itself has certainly reached that type of maturity. So it's a beautiful work, and thank you so much for this beautiful presentation of the work as well. It was really kind of insightful and profound. So thank you so much, Andrew.
Great, and thank you for this really interesting conversation, and for for inviting me here. And I can't wait to see where all this goes.
Brilliant. So that's how we wrap it up. Thank you everyone for coming. We have at 2 o'clock in 1.5 hours roughly, the presentations happening on a Zoom link that you should have, and that will be presentations from participants in the symposium. So I encourage you all to come to that series of presentations. But for now, I think we should just close this session and have some lunch. Thank you very much.
Thanks, everyone.
Thank you. Thanks, Andrew. Bye-bye.